Okay, so hello everyone, welcome to day number 23 of this series, and today we're gonna do this question. So yeah, let's get started. Number 8, explain what is meant by the center of gravity of an object. So the center of gravity of an object is a point where all the weight of the object just acts on just one point, and that is the center of gravity. That point that all the weight acts on at the same time, that is the center of gravity. So it's gonna be number B. I'm not gonna write the A, the answer to A, but I'll do some calculations for number B. Right, so a flagpole of mass 35 kilograms is held in a horizontal position by a cable as shown in figure 4.33. The center of gravity for the flagpole is at a distance of 1.5 meters from a fixed end. So right here, this is a fixed end, right? So this is that. Then this is a cable. It's gonna have a tension force right here. The tension of the cable, the weight here. Okay, so so at the center of gravity of the flagpole is a distance of 1.5 meters from the fixed end. Write an equation to represent taking moments about the left-hand end of the flagpole. Using your equation to find the tension T in the cable. So let's analyze this picture real quick, right? So we can think of this like a moment equation, right? So this is gonna be the pivot right here, and a weight acts down while the tension force, we can actually resolve this vector into two more vector, the horizontal name it Tx, and the vertical I'll name it Ty of the cable, the tension of the cable, right? So in moment equation and stuff, the only thing matters about it is the only matter is the perpendicular distance. So the x this doesn't matter, it gets cancelled out either way. So this x doesn't matter. The only thing matters about it is the whole vertical vector of the tension cable, and this vector keeps up the tension, keeps up the flagpole from falling down, right? And then and then we have another force, it's actually right here. And then because this helps helps the flagpole to not fall down, right? So this helps the flagpole not fall down. So there's another force right here. Okay, so alright, so I have to write an equation to find the tension T. So let's do this. Okay, sorry everyone. So yeah, let's get back to solving this question. So weight goes into a counter, and clockwise moment, like this, and this vertical vector of the cable goes anti-clockwise moment, right? So I have to find the tension of the table, which should be easy. This is 30 degrees, so this is 30 degrees. Okay, so let's name this weight W. Let's name this distance D1, and then let's name this distance D2, right? Okay, so okay, and then let's name this angle theta. So yeah, so let's do the calculation now. So the total clockwise moment, so I can write this. The clockwise moment is gonna be this weight moment. So let's find the weight here. Weight is actually wait again. So the weight is gonna be 25 multiplied by 9.81, and then that will be multiplied by the perpendicular distance, which is the 1.5 meter. Okay, so you just use a calculator for this. So 25 multiplied by 9.81, and then we have we have to use we don't have to use numbers, we have to use symbols for this. I'm sorry. So the weight multiplied by the distance d1. Okay, so this will get WD1. Okay, so now another thing is we do know the counterclockwise moment. So we're gonna do the counterclockwise moment. It is at equilibrium, so the clockwise moment and the counterclockwise moment is the same. So that means WD1 is gonna be equal to counterclockwise moment. Right? Okay, so now you can calculate the counterclockwise moment, which will be the tension force, or the Ty, the vertical force, the vertical factor of the tension multiplied by the distance 2.5 d2. So it's like this. Alright, so Ty multiplied by d2. So this will be the equation for this. So to get tension, right, we need to find the Ty here, and that will be WD1 over WD2. Okay, so let's go to number right here, and then here we can use trigonometry. So with theta right here, and this is a sine. So let's be sine the theta, my bad. Theta equals to the opposite angle, opposite length. I'm sorry, opposite length multiplied by the hypotenuse, right? So hypotenuse right there, opposite length right there. So to get the tension force, I need to divide Ty over sine theta. So just normal algebra here. I just substitute this in WD1 over D2, and then sine theta. The tension force is gonna be WD1 over D2 sine theta. This could be the equation for the tension. Alright, so we're going to use the equation to find the tension in the T cable. Okay, so now let's try to find the tension, right? So theta is 30, W is what is it, 25 multiplied by 9.81, so that would be 245.25 newtons. Distance 1 is 1.5 meters, and D2 it's gonna be 2.5 meters. Alright, so now you need to substitute it in. So T equals to 245.25 multiplied by D1, I believe, which is 1.5 over D2 sine theta. Right. So I'll just use the calculator for this. So 245.25 multiplied by 1.5 over 2.5 sine 30. That will get about 294.3. This will be tension force, it will be newtons. So it's going to be the tension force. Tension force is going to be 294.3 newtons. Alright, so now let's go to question number 2. Determine the vertical component of the force at the left end of the flagpole. So talking about this, the weight is 245.25 newtons. We don't know the vertical tension force, so we can use we'll find the vertical tension force in this, which will be 245.25 multiplied by distance 1.5 over D2, which is 2.5. About like 147.15 newtons. So as you can see, like the weight is 245.25 newtons, And then the only force, the only force that is opposing the weight are these two, and this is 147.5. So to find this, right, to find that, we have to do, so these two vectors are supporting the weight. So the two vectors, so ty. Now let's name this vector. What should I name this vector? Like, I think phi or something. Phi dot c, vertical component or something. No, it's not multiplying. I did add a plus vertical component equals to the weight. We know the tension force. The vertical component of the tension vector will be 147.15 plus vertical component equals to weight, which is 245.25. Okay, and then we can find the vertical component by just subtracting these two values. Minus 147.15. And then this will get vertical component 245.25 minus 147.15. About like 98 newtons of force. So this is gonna be 98 newtons. So yeah, guys, so this will be the end of today's episode. It's a long question, so I'm only doing one question today. So yeah, I'll see you guys tomorrow. Goodbye.